Imagine a single server goes down. At home, a crashed computer is, mostly just a personal annoyance.
Yeah, you'd lose a browser tab or maybe a document you forgot to save.
Right, you just restart and move on.
Yeah.
But imagine that single server going down means an entire hospital's digital medical record system just freezes right in the middle of a surgery.
Oh, wow. Yeah, that's terrifying.
Or a global financial trading platform goes completely dark for, 10 whole minutes. When you step into the world of enterprise server administration, a crash is not just a glitch.
No, absolutely not. It is a massive high-stakes environment.
Exactly. It's a multi-million-dollar event. It's an entire ecosystem potentially grinding to a disastrous halt.
Every single second of downtime carries this colossal cost, and not just in dollars, but in reputation and, well, operational safety.
And that is exactly why we are so glad you are joining us for this deep dive today. Our mission is to thoroughly explore a study guide for a very specific, very important credential.
Which is the D-Pe-Oe-01 exam.
Yes, the D-Pe-Oe-01. Now, whether you are actively studying to pass this exam, or you just want a rigorous, behind-the-scenes crash course in how enterprise servers are actually administered in the real world, consider this deep dive your conceptual flight simulator.
I like that. We're putting you right in the cockpit.
We really are. And to fly this plane, it really helps to understand exactly what this exam is testing.
It does. And the structure of the assessment really reflects the harsh day-to-day realities of server management.
What's the exact breakdown from the source?
According to our sources, it's incredibly deliberate. Server management makes up 22% of the exam.
Okay, 22%.
Yep. Then server maintenance is 16%. Troubleshooting is another 22%.
Makes sense that troubleshooting is so high.
Right. And then server monitoring is 20%. And finally, system administration rounds it out at 20%.
Okay, let's unpack this. Because looking at those categories, I realized that managing a server ecosystem is essentially like running a small, highly secure city.
Oh, that's a really good way to put it.
You have to build the foundational infrastructure, you have to police the borders, monitor the traffic, and you absolutely need an emergency plan for when a disaster strikes.
That is a perfect analogy.
Yeah.
Because you can't just plug a rack of machines in, turn off the lights, and walk away.
Right. And before you can troubleshoot a server or, fix a pothole in our city, you have to deploy and configure it correctly in the first place.
Exactly. You need that foundation.
So let's get into building the foundation. We are going to go step by step, question by question through this practice material. We'll look at exactly how the exam frames these challenges.
Sounds great. Let's do it.
Here is question 1. It asks, in Open Manage Enterprise, what is the primary purpose of creating a configuration baseline?
Okay, a baseline.
And it gives us 4 options to choose from. Option A, to permanently lock all hardware settings. Option B, to monitor real-time network traffic. Option C, to generate automated financial reports. Option D, to ensure servers comply with standard settings.
Well, the correct answer here is D, to ensure servers comply with standard settings.
Makes sense. But why?
To understand why, we really have to look at what a baseline actually is in this context. A configuration baseline defines what administrators call a known good set of configurations.
A known good set.
Right. It is the absolute gold standard for how your servers should be set up.
So it's literally like an architectural blueprint for a city. You hold the blueprint up next to the actual building to make sure the contractors didn't randomly add a third doorway or leave out a load-bearing wall.
Precisely. Because in enterprise IT, we worry constantly about this thing called configuration drift.
Configuration drift? What is that?
That's when an admin makes a quick late-night hotfix to a server and just forgets to document it. Or maybe a software update tweaks the setting in the background.
Oh, I see. So things change without anyone noticing.
Exactly. Over time, your servers drift away from that secure blueprint. So the baseline allows you to compare real-world settings against that blueprint to quickly detect those deviations.
That makes total sense. And looking at the other options, you can see how they try to trick you, or in some cases are just delightfully absurd.
Like option C.
Yeah. Obviously, your server hardware management software isn't there to generate your corporate tax returns, so we can throw option C, automated financial reports, out immediately.
Right. Totally irrelevant. And option B, monitoring real-time network traffic, is a completely different domain. That's handled by network monitoring tools, not hardware configuration baselines.
Okay, what about option A?
Option A is the tricky distractor. It suggests baselines permanently lock hardware settings. But it's not about permanent, inflexible locks.
It's just about comparing things.
Yes, it's about detecting deviations so you can take corrective action. You always need flexibility in IT.
Yeah.
You can't just permanently lock everything.
Got it. Okay, moving on to question 2, which deals with deployments. It asks, what is a key benefit of using the iDRAC Group Manager feature in a small deployment of PowerEdge servers?
Another good one.
Our 4 options are: Option A, it enables automated operating system deployments across all servers. Option B, it integrates directly with third-party virtualization software. Option C, it provides one-to-many management without requiring a separate dedicated software console. Option D, it aggregates all storage arrays into a single logical volume.
What's fascinating here is how option C addresses a very specific logistical pain point, making it the correct answer.
Okay, option C.
But first, let's briefly clarify what iDRAC actually is, because it's a huge part of this exam.
Yes, please. We throw that acronym around a lot. What is it?
It stands for Integrated Dell Remote Access Controller. Basically, it is a tiny, independent computer built directly onto the server's motherboard.
Wait, a computer inside the computer?
Exactly. It has its own network connection, its own processor, and its own memory.
Wow.
So even if the main server is completely powered off or the operating system has completely crashed, you can still log into the iDRAC to turn the server on, view the screen, or change settings.
It's an out-of-band lifeline. That's incredibly useful. So what does the Group Manager feature do?
Normally, to manage a whole fleet of servers, you'd need to set up a dedicated management server running really heavy software.
Right, which sounds like a lot of work for a small setup.
Exactly. But option C is correct, because iDRAC's Group Manager allows you to manage multiple PowerEdge servers simultaneously from a single interface on just one iDRAC.
So it's simplified one-to-many server management built right into the existing hardware.
Precisely. It completely eliminates the need to install a separate, heavy management console for small deployments. You can just do your batch updates and monitoring across multiple servers efficiently.
That's super efficient.
It is. And the other options miss the mark entirely. Option A, automated OS deployments, and option B, integrating virtualization.
And option D, aggregating storage arrays.
Right. Those are all entirely different tasks requiring different tools. Group Manager is strictly about hardware management accessibility.
It's about having the right tool for the right size job. Okay, question 3. This one is about getting the software onto the hardware. It asks, what is the primary function of the Dell Lifecycle Controller when installing a new operating system?
Okay, Lifecycle Controller.
Options. Option A, it permanently modifies the operating system kernel for better performance. Option B, it encrypts the entire hard drive before installation. Option C, it virtualizes the physical hardware for faster deployment. Option D, it injects the correct storage and network drivers during the installation process.
The answer here is D. It ingests the correct storage and network drivers during the installation process.
You know, reading this makes me wonder, why do OS installations fail at the hardware level so often in the first place?
That's a great question.
Because if I install Windows on my laptop at home, it usually just works. Why do enterprise servers need a special controller just to inject drivers?
Oh, because an operating system installer, right out of the box, is essentially blind to the highly specialized proprietary hardware of an enterprise server.
Oh, I see.
Your home laptop just uses standard, off-the-shelf parts. But a massive PowerEdge server uses complex RAID storage controllers and advanced network cards.
Stuff Windows doesn't just recognize automatically.
Exactly. If the Windows or Linux installer doesn't have the specific driver, the dictionary to translate its commands to that specific hardware, the installation just halts. It literally can't even see the hard drives.
So the Dell Lifecycle Controller steps in as the translator.
Yes. It streamlines the OS deployment by automatically injecting those exact necessary drivers right into the installation process.
That saves so much time.
It prevents those frustrating failures and cuts out hours of manual steps. It ensures the OS is actually aware of the server's hardware immediately.
That makes perfect sense. It's introducing the software to the hardware so they can actually talk to each other.
Exactly.
And that completely rules out option A about modifying the kernel, which the hardware controller obviously doesn't do. It rules out option B about encrypting drives, which is a totally different security process. And it rules out option C about virtualizing hardware.
Correct. So we've got the foundation built, the OS is installed, and the servers are managed.
But, well, hardware's physical, and physical things eventually break.
They absolutely do.
So let's talk about resilience and bouncing back from massive hardware failures. Question 4, looks at exactly this kind of worst-case scenario.
This is an important one.
The question asks, when replacing a faulty system board on a PowerEdge server, which feature automatically restores the service tag, licenses, and configuration settings.
Let's hear the options.
Option A, rapid fault recovery. Option B, chassis management controller. Option C, open manage integration. Option D, easy restore.
The correct choice is option D, easy restore. This feature is just an absolute lifesaver for system board replacements.
No, wait, let me push back on this a little bit.
Go for it.
Because replacing a whole system board sounds like an absolute nightmare. You are pulling out the brain and the entire nervous system of the server. How can a software feature just, fix that?
It sounds like magic, doesn't it?
Yeah. Where is all that configuration data even living if I just threw the old motherboard in the recycling bin?
That is the perfect question to ask. The secret mechanism here is that the server's critical identity data doesn't only live on the system board.
Oh, really? Where else is it?
Dell servers actually back up this critical information, like the unique service tag, the paid software licenses, and the BIOS configuration settings, onto a separate, dedicated flash memory chip.
Where is that chip?
It's often located in the physical front panel, or the chassis of the server itself.
Oh, so the chassis itself remembers who it is, even if you swap out its brain.
Exactly. When you physically install the new blank system board and power it on, Easy Restore detects the mismatch.
It knows it's a new board.
Yep. It asks you, do you want me to pull the identity from the chassis flash chip and write it onto this new board? You just say yes, and it automatically restores everything.
That is incredible engineering.
It graphically reduces downtime and entirely eliminates the human error of trying to manually type in 30-character license keys during a really stressful hardware outage.
Yeah, nobody wants to be doing that at 3 a.m. So options A, B, and C are just incorrect feature names or entirely different tools.
Right. Rapid fault recovery sounds totally made up, and chassis management is for blade servers. Easy Restore is the magic button here.
Let's look at another type of failure. Question 5. It asks, during the deployment of a new PowerEdge server, what is the primary function of the PERC battery or non-volatile cache module?
Another hardware question.
4 options. Option A, to provide temporary power to the cooling fans. Option B, to keep the management interface accessible during a blackout. Option C, to preserve unwritten data during a sudden power loss. Option D, to maintain the system clock accuracy.
This is a really critical one for data protection. The answer is C, to preserve unwritten data during a sudden power loss.
Okay, we need to define PERC. First, PERC.
Right. It stands for PowerEdge RAID Controller. Basically, it's the brain that manages all the hard drives.
Right. And what about the cache part of the module?
Cache is incredibly fast, temporary memory. To make the server run faster, when the operating system wants to save a file, the RAID controller catches that data in its high-speed cache memory first.
Okay, so it holds it there.
Yeah, it tells the OS, okay, saved, and then it takes its time physically writing that data down onto the slower spinning hard drives.
Oh, wait. If the power dies in that exact millisecond, the data is in the temporary cache, but not on the permanent hard drive yet.
Precisely. If that volatile cache loses power, that data vanishes forever. You get massive database corruption.
Oh, that's bad.
So the PRC battery, or non-volatile module, exists solely to provide enough emergency power to that specific memory chip to safely offload that unwritten data into permanent flash storage. The exact instant power is lost.
It's like a video game's emergency autosave triggering the exact milliseconds someone trips over the power cord and unplugs your console from the wall.
That is a brilliant analogy.
Yep.
It preserves that specific unwritten data perfectly. And that is why the distractors are wrong. Option A, powering cooling fans during a blackout, makes no sense.
Right, fans take way too much power anyway.
Exactly. Option B, keeping the management interface up, would require a massive UPS battery, not a tiny module on a RAID card. And option D, maintaining the system clock, well, that's done by a tiny coin cell battery on the motherboard, not the PERC battery.
Okay, so we've protected the data from power outages and physical breakage. But how do we protect the system from us?
Oh, human error.
Yeah, human error or even malicious software. That brings us to locking the doors. Let's look at question 6. It asks, which iDRAC user privilege level must be assigned to an administrator who needs to update firmware but should be restricted from managing user accounts?
Privilege levels.
The options are option A, read-only, option B, auditor, option C, server control, option D, operator.
This raises an important question about security architecture.
Yeah.
Exactly how much power does any single administrator actually need to do their job?
Right. And the answer to this scenario?
It's D, the operator privilege level.
So this is about role-based access control, the whole principle of least privilege.
Exactly. You don't give the maintenance worker the master keys to the entire bank vault.
No, you just give them the keys to the utility room.
Precisely. The operator level is the Goldilocks zone here. It allows an administrator to perform essential hardware maintenance, like updating firmware, which is exactly what the prompt asks for.
But crucially, it restricts them from highly sensitive operations.
Yes, such as creating, deleting, or modifying user accounts.
Because if a low-level admin gets phished and a hacker gets their credentials, you absolutely don't want the hacker to be able to create a brand new invisible master account.
Exactly. You want to limit the blast radius. Options A, B, and C just don't offer that specific balance of power. Read-only or auditor wouldn't allow firmware updates at all. They can only look, not touch.
And a higher level, like server control, might grant way too much access. So operator is the correct answer.
You got it.
All right. Question 7 dives into stopping bad code before it even starts. It asks, which security feature verifies the digital signature of the operating system bootloader to prevent malicious code from executing during startup?
Let's hear the options for this one.
Option A, system lockdown. Option B, secure boot. Option C, cryptographic erase. Option D, hardware root of trust.
The correct answer is B, secure boot. This feature is all about system integrity and malware prevention right at the starting line.
How does it actually work mechanically? How does hardware verify software?
It uses cryptographic keys. At the factory, trusted digital signatures, which are basically complex, unforgeable math problems, are burned into the server's firmware.
Burn right in.
Yep. So when the server powers on, before it even looks at Windows or Linux, it inspects the operating system's bootloader. It checks the bootloader's digital signature against the physical keys stored in the hardware.
So it's literally checking IDs at the door before the club even opens. If your ID is fake, you don't get in.
Right. If a rootkit or advanced malware has secretly altered the bootloader to try and hijack the system, the math just won't match.
And what happens?
The signature fails, and Secure Boot stops the server dead in its tracks. It actively prevents malicious code from executing during startup.
Wow.
Options A, C, and D are real security concepts like cryptographic erase securely wipes a hard drive, for example.
Well,
But they are the wrong mechanisms for this specific pre-OS startup validation phase.
it's fascinating how layered this all is. But even with perfect deployment, seamless recovery, and lockdown security, the day-to-day operations of our server city require constant vigilance.
They absolutely do.
When things act up, you need to do the detective work. So let's get into the day-to-day monitoring. Question 8 looks at performance.
Let's read it.
It asks, when analyzing performance bottlenecks in iDRAC, which feature provides real-time graphs and historical data for CPU, memory, and I/O usage?
Okay, 4 options.
Option A, system performance monitoring. Option B, resource allocation log. Option C, workload profiler. Option D, capacity planner. So, what does this all mean?
The correct answer is A, system performance monitoring. This feature in iDRAC gives administrators exactly what the question describes, a dashboard with real-time and historical data on CPU, memory, and I/O usage.
I/O meaning input-output, right, like disk reads and network traffic.
Yes, exactly. It allows administrators to identify bottlenecks right as they happen. But more importantly, the historical data lets them track trends.
Tracking trends seems crucial.
It is. You can see a slow memory leak building up over 3 weeks before it actually crashes the system. You can make informed decisions about workload balancing and hardware upgrades.
Gotcha.
And options B, C, and D are either completely fabricated terms or just incorrect tools for this specific iDRAC capability.
Real-time and historical analysis. You really have to know where you've been to know where you're going.
For sure.
Question 9 gets into what happens when the problem is so complex you need to call in the manufacturer's cavalry. It asks, which component is primarily responsible for gathering system events, hardware logs, and configuration details into a support assist collection?
Support assist collection, okay.
Options. Option A, systems management hardware. Option B, open manage mobile. Option C, iDRAC service module. Option D, lifecycle log collector.
The correct answer here is C, the iDRAC service module, or ISM. Now, we established earlier that iDRAC is a physical chip on the motherboard.
Right.
But because it's hardware, it sits underneath the operating system. It can't easily see what's happening deep inside the Windows or Linux software environment.
It's basically locked out of the upper floors of the building.
Exactly. So what you do is install the iDRAC service module. It is a lightweight software agent that runs within the operating system itself. It acts as a bridge, constantly talking down to the iDRAC hardware.
Like a flight data recorder or a black box inside the OS.
Yes. When things go wrong, the ISM gathers deeply detailed OS logs, software events, and hardware configuration info, and packages it all into a single file called a support assist collection.
And then what?
That file is exactly what Dell support teams use to diagnose complex issues without just guessing. Options A, B, and D are rejected because they simply don't serve this primary internal log gathering function from within the OS.
Enhanced monitoring and support. It packages up the evidence for the detectives.
All right, we've reached our final scenario, question 10.
The last one.
It asks, during the initial boot sequence, the system halts and displays a memory configuration error on the local console. Which tool should be used first to view the detailed historical event?
Okay, what are the tools?
Option A, System Event Log. Option B, Open Manage Enterprise. Option C, Support Assist Interface. Option D, Virtual Console.
The answer is A, the System Event Log, or SEL.
Okay, let me pause you there because I want to play devil's advocate for a second.
Sure, go ahead. If the error is right there on the local console, I mean, it explicitly says memory configuration error right on the monitor, why do I need to go dig through a historical log? Haven't I already found the problem? Can't I just swap the RAM stick and go home?
Well, you've found the symptom, but you haven't necessarily found the root cause.
What do you mean?
If you just swap the RAM, what happens if the new RAM fries an hour later? The System Event Log stores detailed historical records of all hardware events. Our source material points out that when a server halts during boot, the SEL provides the crucial first point of reference.
So it tells the whole story leading up to the murder.
Exactly. By checking the SEL, you trace the problem historically. Did this memory module throw a dozen tiny correctable voltage warnings last week?
Oh, I see.
Did the server's internal temperature spike right before the reboot? Maybe it's not a bad RAM stick at all. Maybe it's a failing voltage regulator on the motherboard that is actively damaging the RAM.
And the log would show that.
Yes. The SEL gives you the data to stop guessing. The other options, B, C, and D, are simply incorrect initial diagnostic steps for this specific type of halted system error.
It's all about historical hardware event tracking. You can't just treat the symptom, you really have to investigate the history. We've seen how features like Easy Restore and the Lifecycle Controller now automate incredibly complex tasks that, historically, took humans hours of manual labor.
Oh yes, so much automation now.
If enterprise server hardware is becoming increasingly capable of self-configuring, checking its own security IDs, self-diagnosing, and essentially self-healing.
Where does that leave us?
Exactly. What will the human system administrator's job actually look like 10 years from now? Will we still be the active mayors of these massive digital cities, or will we just be the ones turning on the lights and letting the servers run themselves? Something to think about. Until next time.